Hello everyone, my name is Ralf Wondratschek. I'm currently at a company called Evernote, and today we are talking about background jobs or job scheduling on Android and how you can run something in the future on Android. If this talk somehow sounds familiar to you, it might be because I gave a similar talk last year about those and existing job scheduling engines, but then this year something changed because Google came up with a new API. So we will cover the new API, maybe also a little bit of history. But if you're really interested in those older APIs, I highly recommend that you check out the talk from last year. The motivation stays the same, basically. What we try to do here is we improve for battery life. You want that the system batches jobs and saves battery, and you want to have in-exec jobs. That means you don't really want to run your job in 2 hours. Maybe you want to run your job in 2 hours and 50 minutes when the system thinks it's best for the device. So we are trying to solve for battery life, but then the other thing we try to solve, we want to have a guaranteed execution. If I set up a job that should run in 2 days, I want it to run. If the device reboots or does something else in the background, you shouldn't worry about this. In the end, your job should run. I mean, you scheduled it, you want it to run. Then you can have multiple requirements, like you want to set a specific network type, or the device must be charging, and those kind of things. And then, like I said, the system should try to batch these jobs to optimize for the whole device health and not just for your app instance health. So let's go a bit back in time and start with the AlarmManager. The AlarmManager was one of the very first APIs. So we really go back when Android was first launched in 2008. And the AlarmManager was great because it allowed you to easily schedule something in the future on all available devices, and it uses a pending intent. So the usage was straightforward. You wrap something in a pending intent, and it just works. The problem of it is it doesn't respect the device state. So you couldn't say something like, fire this alarm only when the device is currently charging. So it took a while until Google changed something, and the first change came with Android KitKat in 2013. And there Google changed the API. Suddenly, all those alarms that you scheduled, they were in-exec. Before, they were always exec. You said, run this in 2 hours, and it ran in exactly 2 hours. Now all of them were in-exec. And the reason for this is, of course, Google wants to batch those alarms and improve for battery life. And instead, we got a new method for scheduling exec jobs. Then 1 year later, Android Lollipop was announced, and we got a new API called Job Scheduler. Job Scheduler is better than AlarmManager because it doesn't require you to write as much boilerplate code as AlarmManager, and it has a nice fluent API for you. And it also respects the device state. So you could say something like, run this only with a connected network. Problem again, especially back in this year, it was still a new API, and it took a while until all of those devices updated. And if you're still targeting something below 21, below Lollipop, then you still cannot use it everywhere. Next year, Android Marshmallow was announced, and Android Marshmallow came with a new power-saving mode called Dose, and actually another one called App Standby. And as an app developer, you don't really need to understand the details. The only takeaway for you should be that the device might delay your jobs. Instead of running it in 2 hours, it actually could happen in 3 hours when the device wakes up. So as you can see in the graphic, the device is running, and after a while it goes into this dose mode where it really saves a lot of battery. It turns off the network and other things. No application is allowed to run. And after some time, the maintenance window starts where all those batch jobs actually run. And after this, it goes back into dose mode and saves a lot of battery. And again, and at the same time when Marshmallow was released, the AlarmManager API changed again. So suddenly the alarms didn't run anymore when the device was in dose mode, even though the alarm was set up as exec. Instead, they had a new API to run exec jobs while the device is in dose mode. same year, I think it was, where they released the GCM Network Manager, and this class was poorly named. It implies that it's only running with the Google Cloud messaging, but that's not true. It's really just a job scheduling engine, similar to Job Scheduler. And it's actually really nice to use. It has a little bit better API, and it works nicely. The cool thing about it is also that it runs on all devices out there, basically API9. The problem is that it requires the Google Play services. So you have to check first, are the Play services available on my device? If not, yeah, use a fallback. So this was annoying. Also at the same year, we at Evernote released Android Job. Android Job is basically a wrapper around those existing APIs like AlarmManager, Job Scheduler, and GCM Network Manager. Yeah, and it takes a lot of work away from you, but I will cover this a little bit later. Next year, in 2016, Google released another library called Firebase Job Dispatcher, and the intent of the Firebase Job Dispatcher was to provide something similar like Android Job, a wrapper around existing APIs. And it uses exactly the same API like Job Scheduler, so that was nice if you were familiar with this API. The problem is that it only wrapped one API, and that's the GCM Network Manager. And here again, you have the same constraints. If the Play services aren't available, you cannot use Firebase Job Dispatcher. So it didn't really solve the problem. Last year, Android Oreo was released, and Android Oreo was way more aggressive than the previous releases when it comes to saving battery. They introduced new background service limitations. For example, you're not allowed to start your application anymore while your app is currently in the background. And then they also removed a couple of broadcasts. So in the old days, you were listening for network changes with a broadcast receiver on your manifest. Suddenly, those things didn't work anymore. But if you think about it, in the end, it's good for your users or for any person that uses an Android device because you want to save battery and not run out of energy as fast. Same year, they also released the Job Intent service. The Job Intent service is really just a replacement for the Intent service and not a job scheduling engine. It's part of the support library. And the good thing about it is it respects the device state. So it allows you basically to start an intent service while your app is in the background. Under the hood, it's using the job scheduler, and maybe it defers the task a little bit. All right, and then in 2018, as most of you probably have heard, WorkManager was released during Google I/O, and WorkManager in the end is also only a wrapper around the existing APIs, and it provides a single API that you can use. And it's part of the architecture components. And yeah, part of the architecture components in Android Jetpack. And I will cover the WorkManager in more detail later. So, as you have seen, there are many, many APIs that you can choose from. And the obvious question is, which one should you use? And the answer to this is usually, it depends on your use case. But my recommendation is, for the short term, you probably want to use Android Job. And in the long term, you want to switch to WorkManager. And the reason for this is this graph, basically. I try to come up with something where you see all the dependencies, how those frameworks and libraries relate to each other. And at the bottom, you have the framework APIs like AlarmManager and the Job Scheduler. And then you have all the other libraries built on top of that. And at the very top, we have WorkManager and Android Job, which leverage the other libraries and framework APIs. And then here you can see, for example, what WorkManager is in the end using, depending on the device and the device state. And that's what Android Job is using. So let's cover Android Job quickly. I'm curious, who is using Android Job in his projects? Nobody? Okay. Android Job was nice for a couple of years because it was basically a wrapper, like I said, around the existing APIs. And it actually backported many of the features from Job Scheduler to the older API versions. And the good thing about this, you don't really need to worry about anything like this anymore. You just schedule a job and it works, and the library picks the best API for your use case. And then there were many, many, many features backported. The setup is straightforward. You add a dependency so that you can access the library. And then you have to write a little bit of code to set up the library. What is also not that difficult. This job creator interface is there for you to map your job tags to a real job class. And in the end, it looks something like this, where you create your instance. This is convenient because in the end, you can use other libraries like Dagger to inject your classes. So if you want to abstract this away, that's straightforward with the job creator interface. And then we can start using the job. And the API is really simple. You just need to extend the job class and override one method, and here you return a result. So that's easy. Then the interesting part is how you schedule the job, and it's also not that complicated. First, you create a builder object, which has this tag that we then again used in the job creator interface. Then I set up my requirements, like I pass certain extras to this job so that I know which image to use in this case. And then it's also say, start this job now, immediately. In the end, I just called build for the builder object and then scheduled the job. That's it. So let's cover WorkManager now. WorkManager is a wrapper around the existing APIs. It has many features backported to API 14, so you don't need to worry about which device it's currently running on. It automatically chooses the best API for your use case, and then it has many, many features. And if this somehow sounds familiar to you, this is what the requirements were for Android Job. It's, in the end, really, really similar. So let's have a look at the setup. And I will only cover this quickly because the documentation about WorkManager is really good. Instead, I will cover more of those details that you don't find in documentation. So the first thing you need to do is you need to add the dependency. And WorkManager provides also a library for Kotlin, so this is really convenient to use, and I will use this in my slides too. And then there's another dependency for your tests, and I will cover this later too. So let's focus on the setup. After this, once you've added the library, you can start using WorkManager right away. And what you need to do, you need to extend the class worker. And there you need to override one method where you, in the end, return a result, whether the work item should be rescheduled, whether it was successful or failed. And again, if this looks similar to you, the transition from Android Job is really easy. So in the end, you just need to change the class name and the method name, and that's it. It will work. Scheduling a work item is also really straightforward. Similar thing. You just create a builder object for your work item. In this case, I'm using the Kotlin extension functions. Here I also add a tag. This is optional in WorkManager, but it's highly recommended for if you want to debug a problem, because all your work items use this tag if you want to identify one specific request. So you should usually add a tag. And then I define my input data. Again, that's very similar. And in the end, I call build and I enqueue my work request through WorkManager. And same thing here. This is, in the end, almost exactly the same API like Android Job. So that makes the transition easy. But let's not focus on the similarities between both APIs. So if you need to make the decision between Android Job and WorkManager, you want to focus on the differences and when you want to use one API or the other. And those are the differences I identified so far, and let's cover them quickly. And I start with Android Job here. And the first difference is that Android job supports exec jobs. That's something WorkManager doesn't have. So if you have an exec job that you want to run exactly in 1 hour because the user set up a reminder or an alarm or a similar functionality in your app, then that's something WorkManager doesn't have. And the reason for this is that Google is afraid of abusing this API. If you remember, Google tries to solve for battery life, the same thing that Android job does. So they're really scared of this because you don't want to wake up the device unnecessarily. And that's why they don't have to have this method. And they recommend instead using the AlarmManager directly, what is quite a lot of boilerplate code for you. And here, Android job has you covered. Yeah, and the difference here is I just called it exec, and it works exactly the same way. Next difference is daily job. If you have a feature like you want to show a notification every morning, then this should be straightforward to use. That's something WorkManager doesn't have yet. I know that they are working on this, so this might come. Here's the setup, how it looks in Android job. It's actually really easy. You just extend daily job. You override a similar method. Then here in the schedule method, I check first if I've scheduled already a job. If one is there, then I don't need to schedule a new one. I just want to have one daily job. And if there's no job scheduled yet, I do this here. I, again, set create a builder object, can specify requirements, what I didn't need to do here. And then I just schedule the job, and that's it. And here I specify the time window. This job, for example, would run between 5 a.m. and 8 a.m. in the morning. And again, this is a big time window, and that makes it easy for Android to optimize for battery life. Next difference is transient jobs. That's actually an API from Job Scheduler that I backported in Android job. And it's not that often used, but sometimes it can be helpful. The difference between transient jobs and normal jobs is that normal jobs are persisted across reboots, and you don't have this with transient jobs. So if your application dies or the device reboots, then your job is gone. Sometimes it's helpful. The good thing about this API is that you can use real bundles as extras, so you don't need to rely just on primitive types or strings. The next difference is reflection. Android job doesn't rely on reflection, and it works because we have this weird job creator interface, as you remember. This avoids using reflection. WorkManager relies on reflection, and that's something you need to be aware of because it comes with its own progut rules, and if you want to override those rules, you currently don't have any way in the Android Cradle plugin. So these rules are coming from WorkManager directly. I copied them. And you need to be aware of the first ones. It basically means that your worker items or your workers and your input mergers cannot be obfuscated. And that's something you need to be aware of. Next difference, custom loggers. That's also something WorkManager doesn't have yet, but I know it will come soon. So that's coming, and it's probably also there really easy to use. That's how you would set it up in Android job. So you can turn off logging messages or do your own logging, whatever you prefer. But now let's switch to WorkManager. WorkManager is, like I said, really easy to use and the documentation good. So I cover more the advanced features. And one of the best features WorkManager has is chained work, in my opinion. And it basically means that you can chain multiple workers together. Like here in my example, I want to compress a couple of images first, and then I want to upload them. And the compress work item can run in parallel. In my case, for my 3 images, run them in parallel, and then merge all the results together and upload those images. And the API is really easy to use, and that's actually really nice. So that's a normal worker item. The difference is here that I get my image ID as an input as before, then I compress it, and in the end I specify the output data. So you cannot just only specify input data, but also output data for your jobs. Then I have my second upload worker, which should upload all those images. And here I get the input from, or the output from my previous jobs as an input. And since I had multiple worker items to compress those images, I get actually an array. And then for the array, I just do my work and upload all those images. More interesting is how you schedule these jobs, and it's not that complicated and straightforward. As an input, I have an array of images, and I convert each image to a work request. That's what I do here. After this, I create my single upload work request. And here I specify the input merger. So you need to do this. Currently, the WorkManager comes with two input mergers. One that creates an array for you and stores all the outputs from the previous jobs in an array. And that's the one I'm using here. You can also overwrite the results from all the jobs so that you get just one single input. Then as I begin with all my compressed workers, and after this run my upload worker, and then the rest is the same. I just call and queue, and that's about it. So easy to use, really powerful. Testing WorkManager. The API from WorkManager and Android Job are so similar, and they even share their same problems. For some reason, Google decided to go with a singleton, and singletons are usually really hard to test. And the first idea you might have is to test your jobs in a normal JUnit test on the JVM. And that's something that unfortunately doesn't work at all. Because WorkManager relies a lot on the Android framework classes. And you even cannot mock some of the fields like here. If I would want to test my job, I cannot do this because this method is hidden and there's no way for me to mock it. Android Job has the same problem. It's really hard to test. In this case, the test would work and it would be green in the end, but it's not ideal. So the first thing I did here, I just specified the input data. Then I mocked the params object. The API isn't nice, but at least it works. Then I call my job and I get a result back and I can make certain assertions about this. If you want to test WorkManager, I recommend that you use instrumentation tests because it's actually straightforward. The first thing you need to do, the first thing I did is I had to change my schedule method a little bit. Each time you create a Each time you create a work request, the library creates a unique ID for your worker. And that's actually a UUID object, and that's what I also return here, so that I can later identify my job. And we see this in the test. You have the test, that's an instrumentation test that runs on an Android device. My first step is that I need to overwrite the WorkManager instance. In this case, I replace it with the test WorkManager. And keep in mind, once you replaced or created the WorkManager object, you cannot change it. That's really unfortunate. So if you have different kinds of tests, one that relies on the test WorkManager and a couple of tests that rely on the real implementation, you cannot run all those tests at the same time because once the WorkManager instance is set, you cannot change it anymore. Then same thing here. I schedule my job and now I get back the UUID object. And with the UUID object, I can find my work request. At this time already, my job ran already, or my worker ran already. And because test WorkManager allows you to ignore the time window, for example, it runs all your workers immediately. And you can even override those constraints. If you have a worker that needs a network connection, you can override this and start your worker nonetheless. So at this time I already have, my job already ran, I query the result, and then I can make assertions in this case whether my job was successful. In this case, it's true. Observing changes, it's an API that Android Job doesn't have. There's only a way to check if a job is scheduled or is it currently running or did it finish already. WorkManager has a way nicer API for this, where you can really observe the changes. You need to, if you want to observe one specific worker again, then you need to know its UUID. And then you can call get work status by ID, for example, which returns a live data object where you can start observing your job. And then you get callbacks like it's enqueued, it's currently running, or it finished. And if you don't want to use live data, you can also call this in a blocking way with the synchronous WorkManager. Keep in mind that you should only do this on a background thread, because this method in the end will hit a database and you don't want to run database queries on the main thread. My second favorite feature of WorkManager is that it comes with its own job scheduling engine. Remember that I said that it's a wrapper around the existing APIs like Job Scheduler, AlarmManager, and that's the same thing Android Job did, but it relies only on the platform, and that's the most common issue that I receive is, or comment, hey, my job doesn't work after 3 days or whatever, why is this happening? And the answer is, I don't really know. You need to debug this yourself. It relies on the platform, and even the platform has, unfortunately, a lot of bugs. And WorkManager is different because it has its own engine, and it checks manually all the constraints of its workers and doesn't necessarily need to rely on Job Scheduler or the platform APIs. If all the constraints are met and the time window is correct, then it will start your workers manually. So this is really nice and solves a lot of pain points. This is still experimental, so WorkManager also wants to move to an asynchronous API. Imagine you have something like this, where you want to upload an image to a server and gives you back, in this case, an ArcsJava completable. It could also be a Kotlin coroutine or whatever asynchronous API that you use or framework that you use. In Android Job, you cannot do this that nicely. What you need to do is you need to call block and get. This works because the onRun job method is already called on a background thread, but nonetheless, you don't want to use block and get. It's a problem. You often run into deadlocks, so it's not nice. It works, but yeah, WorkManager has something better in this case. Since the latest alpha release of WorkManager, it has a new base class. Previously, I told you that you extend the worker class, and now worker extends the non-blocking worker class. And as the name might suggest, it's not blocking. This is a sample implementation which isn't working yet because the API simply isn't there yet. It's still work in progress, but you can hack around it, and in the end it will actually work, what is nice. So the first thing you need to do here, you extend non-blocking worker, obviously, and then you override the onStart work method. And here, instead of returning a result like success or failure, you get a callback that you later need to call. And I'm doing this here. I'm calling my asynchronous API, and then I subscribe to the result, and I save the disposable even in a variable in case my job needs to stop or my worker needs to stop earlier than expected. I can dispose the connection, and in the callbacks I just invoke this result callback from WorkManager, whether it was successful or failed. And like I said, there's an onStop method. If your worker needs to stop early, for example, because the device loses the network connection, then this method is called, and you can decide what you want to do there. Scheduling a non-blocking worker is exactly the same API. The only problem right now is that this doesn't compile because the extension function expects a worker and not a non-blocking worker yet. So they have to change the whole API from worker to non-blocking worker. That's why I said it's the work in progress, and I wouldn't recommend using this right now. But we see into which direction they want to go with the library. Let's have a look at the implementation of worker, and there we can see that it's actually already using this asynchronous API. Yeah, like I said, worker is extending non-blocking worker. And you find some interesting stuff in the source code. So WorkManager is still an alpha release, and it's meant to change. And the API actually will change in the future. So for example, here we have this to-do where they want to move the result class to the non-blocking worker. And this will, of course, introduce breaking changes. And then here we see the do-work method that you need to override in your worker classes, and we also see that they override this API for the non-blocking worker or asynchronous API, and they simply call the do-work method in a blocking fashion. So like in the sample, this API won't change this much. So the question now is, if you follow my recommendation and start with Android Job and then later move on to WorkManager, how can you actually do this? And you can actually use both in parallel, and this works really nicely. The only thing you need to do, you need to add the dependencies. And I'm explicitly saying here that you should use Android Job in the next alpha release because it has an API for WorkManager. So you get all the good things from WorkManager inside of Android Job, like its own job scheduling engine, what is really nice. You can also turn this on and off. It's done implicitly, so if Android Job finds WorkManager on the class path, it automatically picks WorkManager as the default API. But if you don't want this behavior, you can also turn it off this way. And then if you decide to really move on from Android Job to WorkManager, if you decide to move on, you can just need to remove the dependency in Android Job and transition everything to WorkManager. For existing jobs that you scheduled with Android Job, you don't need to do anything. What I recommend is that you schedule your workers as you would do with a normal fresh install. So for example, if you have a sync worker that syncs all your data once a day to your server, usually when you schedule this worker, you check first if you already scheduled such a worker item or enqueued. If you didn't, then you do the job or you enqueue the work, otherwise you skip it. And I would treat it the same way, and then you don't run into issues. If you really want to copy jobs over, then you still can access the database, because both libraries in the end have a database to store all the information, and you can read it and copy data if you feel the need to do this. Okay, are there any questions? I might start with the first question in case somebody is curious. So WorkManager is with this parallel API and the chaining workers, it somehow sounds similar to RxJava. So the question comes up, should I replace async task, RxJava, or with whatever async API with WorkManager? And I need to quote the documentation here because it gives a clear answer, and the clear answer is no, you shouldn't do this. WorkManager is really meant for tasks that you want to do in the future and where your UI doesn't need to rely on. For example, if you load an image from the disk, you still want to use a background thread, a normal background thread. And WorkManager is an overkill for this. Android Job will be deprecated at some point in time. Right now it's not. But then we also have seen that some features aren't supported in WorkManager, like an exact API, and apps out there want to use this feature. So what's the recommendation there? I don't have a clear answer for you. If you want to use exact jobs and WorkManager at the same time, you can use both libraries like I showed you. And it would work. So it depends on you. It's really on your use case. Do you want to add another dependency or not? But in the end, Android Job will be deprecated at some point in the future. Okay. That's all I have. Are there any questions in the audience? All right, then, yeah, thank you very much.